warning you right now. So just be ready. I don't know, grab a cup of coffee or something to help keep you awake. But it's important, very important stuff that we're learning today. Okay, let's go with Donnell.
Here.
Isaac. Ishi. Madison.
Here.
Kayla.
Here.
John.
Here.
Alex. Garcia. Jasmine.
Here.
Matthew.
Here.
Brandon.
Here.
Morella.
Here.
Jeshua.
Here.
Annika.
Here.
Eric.
Here.
Gracie.
Here.
Carlos.
Here.
Jose. Ethan.
Here.
Natalia.
Here.
Jaylene.
Here.
Giovanna.
Here.
Taylor.
Here.
Jay.
Here.
Gianna.
Here.
Jacob.
Here.
Roberto.
Here.
Ariana.
Hi.
All right. Okay, here's I have absent. I have Isaac, Ishi, Alex, and Jose. Isaac Aquino, Ishi Blanco, Alex Garcia, and Jose Orozco. Isaac, are you here? Ishi, are you here? Alex Garcia, are you here?
Here.
Jose Orozco.
Present.
Isaac and Ishi have absent. Okay. All right. We have okay, crazy day. Hey, did you guys print the unit circle? If you can, if you have the ability, I highly suggest you get it. It's going to make your life a heck of a lot easier. Of course, you can draw it. It'll make your life a heck of a, like, way easier. This unit circle. It's going to show us how to graph sine and cosine, okay? So, here we go. Before we do the unit circle, so make sure you have, if you have this, that would be great. All right, I'm already getting glares here. Okay, but moving on. Before we get to the unit circle, let's go over some review what we did yesterday, because it's important that we understand what we did yesterday, okay? And I'm going to move kind of fast. Look, we're going to learn how to graph that right there. Graph that. That's what we're graphing. There's my notes from last class. Okay. Topic. This is 8.3. Topic is the unit circle and graphing. Am I sharing? I'm not even sharing. Am I sharing? I'm not sharing. Sorry. No. There we go. I'm like going too faster than I, for my own good. Okay, and graphing sine and cosine. Okay, so we have the unit circle. We're going to graph sine and cosine. So let's go with what we did before. Okay. Let's go. Let's do 3 triangles. 3 right triangles. 3 special right triangles. Look, I'm using a tech deck as my, that kind of cool? Tech deck. Tech deck. Tech deck. Tech deck. Okay. This triangle, let's call it a 30, 60, 90 triangle. This one will be a 45, 45, 90 triangle. And this one we'll call a 30, 60, 90, but this one will be my 60, 30, 90. We'll go like that, okay? All right. I'm sorry they're not drawn to scale, but for each of these triangles that you are drawing with me, it's very important that you draw this with me. The hypotenuse is going to be 1 unit for all of these triangles. The hypotenuse is going to be 1 unit. Okay? Now, remember, as a reference, sorry, I'll leave that there so you guys can copy that down. Okay, so we have to figure out the other sides of the angle based on the hypotenuse being 1. Now remember, try to cover everything here. 45, 45, 90 triangle. If this is x, this is x, this is x square root 2, right? We multiply by square root 2 to go here, but if I want to figure out x, which is what I want to find out here, I want to figure out the x, I divide by the square root of 2 to get this, right? This one, to get this x, I multiply by 2 to go here, I divide by 2 to go here, right? Divide by 2. Okay, so my x is here. If this is 1, how do I figure out the length of my 30? Annika, how do I figure it out?
Divided by root 3. Oh, just kidding. Wrong one. Divided by 2.
Yes, very good. And I need to show you guys again if you need to see. We have this one. We want to go here. Multiply by 2 to go here. We divide by 2. Annika, what's 1 divided by 2?
1/2.
So the length of that is going to be half, which makes sense. The 30 is always half of the 1, right? Now, what is the length of this side going to be? My 60. Remember, my 60, which is here, is x times the square root of 3. Okay, so what is this going to be, my 60? What is that going to be based on yesterday? Ariana, what is it?
Is it 1/2 square root 3?
Okay, good. Or 1/2 times the square root of 3. I'm going to write here. 1/2 times the square root of 3, which is x times square root of 3, which is square root of 3 over 2. Just leave it as that. Okay, 45, 45, 90. I have my hypotenuse. 45, 45, 90. To get the hypotenuse, I multiply the square root of 2. But if I want to get the x, I divide by the square root of 2, right? Okay. So what is the length of this side right here? This side right here that I'm pointing at with the 45. Or you could do this one too, but let's just focus on this one. They're the same. Well, what's this one here? The length of that. How would you figure it out? If you can't calculate it, tell me how you would figure it out. Brandon, how would you figure this out? The length of this side right here.
Is it divided by root 2?
Divide what by root 2? Yes, but by what?
1.
Divide what by root 2? Yes. And so you do 1 divided by root 2. But remember, we can't have the root 2 in the denominator. So multiply by root 2 over root 2, which becomes 2. 1 times root 2 is root 2. So this is root 2 over 2, and this is the same, root 2 over 2. Now again, we have this is the same triangle, except here's my 60. So what should the length of this be? The length of the 60, what should that be? Because it's the same as this, except it's flipped around. What should the height be of that triangle? Carlos, what do you give it to me, Carlos?
1 square root 3. Is it wrong?
How'd you get that?
I don't know.
Okay. It's not that hard. I hate it when a teacher says that, but what I mean is it's the same as this triangle, homie.
Root 3 over 2?
Yes, opposite 60 is root 3 over 2. Do you see, Carlos, do you see the connection?
Oh, yeah. Yeah, I see it now.
Okay. So, Carlos, what should the 30 be?
1/2.
Very good. Okay, so those are very important for our unit circle that we're going to have to do. Now, bear with me. I feel like I should draw another triangle here, make it bigger, use my tech deck. I got another question for you. Make this bigger. You don't have to draw this one if you don't want. I just want to make a point here. Okay, same thing. I'm just drawing this again. You always have. You don't have to draw it because it's another 30, 60, 90. Remember, this is 1. This is 1/2, and this is root 3 over 2. Okay. Now, here's my question for you. What is cosine of 30 degrees in this triangle? SOHCAHTOA. Ethan, what is cosine of 30 degrees?
Square root 3 over 2 over 1.
Very good. Ethan, hang on a second. Root 3. Can you read my little handwriting there? Root 3 over 2 all over 1. Carlos, you with me?
Yeah.
What is anything divided by 1?
1. I mean,
Carlos, what's 7 divided by 1?
7.
Very good. Carlos, what's 45 divided by 1?
45.
Great. Carlos, what's root 3 over 2 divided by 1?
Root 3 over 2.
So cosine of 30 degrees is equal to root 3 over 2. Now, what would sine of 30 degrees be based on this triangle? Okay. Let's go with Donnell. What's sine of 30 degrees?
Sine of 30 is 1/2 over 1.
Which would just be 1/2. And by the way, if you took your calculator, and you just did sine of 60. Like here, look here. See my calculator? Sine of 60. Sine of 60. Oops. I'm sorry, not sine of 60. Sine of 30 is what we did, right? Sine of 30 is 0.5. Okay? So that's a key thing we got to know there. The other thing is this. Imagine if this was a coordinate plane. This is y. This is x. The coordinates of this point, right? Imagine this was an xy plane. And I go this far, root 3 over 2. And I go this distance, root 3 over 2. This distance is 1/2. If this was a coordinate plane, the x-coordinate of this would be root 3 over 2. The y-coordinate would be 1/2. And remember, cosine of 30 degrees is root 3 over 2, which is my x. And sine of 30 degrees is 1/2, which is my y. Cosine equals x, sine equals y. And then same thing with the 45, 45, 90 triangle, and I'll do that really quick. And then we'll get to the unit circle. But just so that you understand, if I do the 45, 45, 90, again, I'm going to do this very quickly. Let's see. Woo! And we go, woo, tech deck. Uh-oh, it's not going to fit. Tech deck. Oh, no. Tech deck, tech deck. Okay, 45, 45, 90. Again, you don't have to write this down. We said this is root 2 over 2. This is root 2 over 2. And this is 1. Okay, so again, cosine of 45 degrees is adjacent over hypotenuse, which is root 2 over 2 divided by 1, or root 2 over 2. So cosine of 45 degrees is root 2 over 2. And then sine of 45 degrees is going to be opposite over hypotenuse, which is root 2 over 2 divided by 1, which is root 2 over 2. And again, these coordinates would be, I'd go x this way, y that way, root 2 over 2, root 2 over 2. If this was a coordinate plane, my y-axis, my x-axis, and then we get this root 2 over 2, root 2 over 2. My x is root 2 over 2. My y is root 2 over 2. Cosine is equal to x. Sine is equal to y. Okay. Are there any questions before I move on? Because we're getting out the unit circle. Did I lose all my stuff? Should I put any of those pieces of paper back? I'm flipping like crazy. Okay, let's do the unit circle. You guys ready? This thing has to do with those triangles. Triangles, sensei. All I see is one big circle. Okay. You guys ready to fill out the unit circle? Stop me if I'm going too fast. Okay, I'm going to start. 10 seconds. Unit circle's all set up. 5, 4, 3, 2, 1. Okay, this unit circle is based on the 30, 60, 90 triangle and the 45, 45, 90 triangle. Notice these little circles here are our degrees. How many degrees? See how this makes an angle here? So this is how big this angle is. This right here. We're going to start off with 0 degrees. And then we're going to open the angle up. And my first angle is going to be 30 degrees. And they're going to open it up again. 45 degrees. And then the last one, well, in this little quadrant will be 60 degrees. And straight up and down, we got a full 90 degrees. Notice these big, see that there's a big angle, little angle in between here. The little ones, I'm increasing by 15. The big ones, I'm increasing by 30. 0 plus 30, 60 plus 30 is 90. Notice this is a big one, so I'm adding another 30 degrees to this 90. 90 plus 30 is 120 degrees, right? And then I increase by a little bit here, add another 15. So this is 135 degrees. Another 15, 150 degrees. And then let's add another 30, 180 degrees. Then another big one, add another 30. This is 210. 210 plus 30 is 225. 225 plus 30 is, am I going, you can see that, 240. I'm sorry, 225 plus 15 is 240. 240 plus 30 is 270 degrees. Big angle, add another 30. 300, add another 15. 315, add another 15. 330, add 30. 360 degrees, which makes sense because we went all the way around. Okay, that's the first part of the unit circle, just filling out the degrees. Gianna, how am I doing? Am I going too fast?
No, you're good.
Okay, cool. Did you fill out all the degrees, Gianna?
Yeah.
How about you, Isaac? How am I doing?
Almost done.
Okay, should I stop for a little bit? Okay. Now, the thing about the unit circle is the reason why we call it a unit circle is because the radius is 1 unit long. It's not feet, inches. It's just a unit. It's just 1. This radius is 1. 1 from here to here is 1. From here to here is 1. From here to here is 1. This is 1. 1. The radius is 1. Just like our little triangles here, right? We had the hypotenuse as 1. And these radiuses are going to be little hypotenuses of all our triangles, okay? So, if this is 1 on a coordinate plane, what I mean by coordinate plane, the XY axis, right? If I have a coordinate plane that looks like this, now this point right there, that's my X, that's my Y. The coordinates at this point would be 1, 2, 3, 4. It'd be 4, 0, right? This one would, right here, would be 0, 1, 2, 3. This point right here would be 1, 2, 3, 4, -4, 0, right? Got the negatives there, right? And then this, let's say this point right here, I'm just picking random points. This would be down -3 and X is 0, right? Notice how, this direction's positive, this direction's negative X, this direction's positive Y, positive X, negative Y, right? So the same thing here. This will be my positive X, positive Y, negative X, negative Y. Okay, here we go. The coordinates of this point right here, if my radius is 1, let's see if I can ask someone, what would the coordinates of this point be? This is my X, this is my Y. What would they be? Let's go with J. What do you think? What would the coordinates of this point be right here?
0, 0.
0, 0 would be here in the middle. I moved over 1 unit.
1, 0.
Correct. Correctamundo. I go over 1, I go up 0. Okay, cool. That's the easiest one. No, it's not the easiest one. There's some easier ones like that. So this point right here, notice a couple things. This is 30, so this is going to be right here. It's going to be my 30-degree triangle, right? It's 30 degrees. If I was to make a triangle here, it goes straight here like this. Boom. There's my right angle as best as I could. Where's my sheet of paper? Where'd it go? it'd be this triangle right here, right? Notice my coordinate plane. I go this way for my x. See how far I go for my x? And I go this much up for my y. See how far up I go for my y in my 30, 60, 90 triangle? So the same thing here. Roop, roop. Take note. What's my x coordinate and my y coordinate? See if anyone can get this. Let's see. Let's go with Joshua. What do you think it would be? My x and y coordinate for this point right here. Tough question. Hard question.
I need help.
Sorry, I'm not showing it to you. What would my x, y coordinate be for this point? Was I this point right here?
I need help understanding.
Joshua.
Yeah.
Do you see my 30, 60, 90 triangle here?
Yeah.
Okay, cool. You see my y-axis and my x-axis? Can you kind of see that?
Yeah.
Okay, you see this point right here?
Yeah.
Okay. What's my x and my y to get to this point? Based on my 30, 60, 90 triangle, this being 1 unit, what's my x?
√3/2?
Yes. So I go over √3/2. It's the same thing here. It's the same triangle.
Okay.
Then what's my y? Do I need to put this up here again?
1/2.
How far do I go? 1/2. So make sure you put √3/2 and 1/2 right there. Now I have a 45, 45, 90 triangle. I have this one here. 45, 40. Let's look at our 45, 45, 90. Which is right here. Right? I have my x and my y. If the radius is 1, see my x, y axis? X, y for my coordinates for that plane. Remember, they're going to be equal because it's a 45, 45, 90 triangle. What are my coordinates for this point right here? Let's go with John. Give it to me, John.
Would it be √2/2?
That's from my x. What about my y?
1/2 or 1.
See? √2/2, √2/2.
Oh yeah.
My x is √2/2 for 45, 45, 90. My y, how far up am I going?
√2/2.
Very good. √2/2. You guys see that? It's all the x's and y's. Now I have my 60-degree triangle. Now this is going to be the same as, this is still a 30, 60, 90 triangle. Did I do a 30, 60, 90? I did a little one here. So here's my 60-degree one, right? To get to this point, what's my x and what's my y? Because my 30 is here now, so this is the shorter side. And my y is up here. What's my x? What's my y? Okay, you guys look at that. I'm going to call on you. What's my x? What's my y? Here we go. Oh, Sensei, wait. I want to see. Morella, what is it? What's my x?
The x is 1/2 and the y is
Yes.
√3/2.
Nice. Thank you. You make me want to cry. You guys got that quickly, like tears of joy. Okay, now here's an easy one. My unit circle is, my radius is 1, right? See that there? I just go 1 straight up. What are my coordinates of this point right there? Matthew.
1, 0.
Flip it, flippy floppy it.
Oh, 0, 1.
Yeah, because I go up 1, right?
Yeah.
Okay, now look. Everyone look here. Look at this point right here. You guys see this point? And this point with my purple pen and this point with my finger. How high is this point? How high is that point right there? How high is it? Right? How high is that point? Let's go with Roberto.
√3/2. That's how high it is.
Yep, that's how high it is. Roberto, can you tell me how far across it goes?
1/2. 1/2.
Okay. Yes, you are correct. However, remember that coordinate plane, we're going in the negative direction, so it'll be -1/2. Does that make sense to you or no?
Yeah, it does make sense.
Okay, cool. Now look at this one. It's the same height as this one over here. By the way, it's another 45, 45, 90 triangle, but we know the height is the same. How high is this point right there? Let's go with Taylor.
√2/2.
Yeah, we got √2/2. And the distance is going to be the same, Taylor. So what's the distance going to be?
-√2/2.
Very good. Okay, again, the height is the same as this one. How high is this one right here? Let's go with Giovanna. Sorry, I'm flipping back and forth too fast. So Giovanna, how high is this one right here?
1/2.
1/2. And what's the distance? From...
-√3/2.
Very good. Then we can go to this. Just so you know, I'm just going to keep going. We're going to say this is actually -1 over and 0 up. Because I go -1. Now, look at these two. Notice they're the same distance going this way, right? So we have -√3/2. I'm just going to start filling it in. -√3/2. And the height is going to be the same height as this, except the negative, -1/2. Do you see the pattern there? See how they're the same? This one and this one are the same distance in this direction, going this, right? And they are -√2/2. And the distance down is the same as this one going, so this is -√2/2. Madison.
Yes.
Am I going too fast?
No.
Okay. See if you can you figure this one out, Madison?
Yeah. -1/2 and -√3/2.
Yes, perfect. It's this one. It mirrors this one right here. Very good. Any questions? Am I going too fast? Let me know if I'm going too fast, anyone. You got to speak up if I am. Some of you said I go too fast in the comments, so please speak up. Okay, so I'm going down -1, so I go x is 0 to -1. And then this one, right? Okay, so these coordinates here, you can see that these are the same height. So this would be -√3/2. And these, it's going to be the same distance as this. It's going to be 1/2. Or this, positive, right? Notice that y is negative, the x is positive. So these are going to be the same distance across, same height. So -√2/2, and it's going to go across the same as this one, √2/2. And then these are the same height, so -1/2, and then -√3/2. I'm sorry, positive √3/2 is the same distance as this. And then that's that. Almost done with the unit circle. Okay, I'm going to leave this up. Are there any questions? One more blanks to fill out. How are we doing on time? Okay, here we go. Now, these points right here are going to be the angle measures, but in radians. We have to, when we graph these, we're going to graph them in radians. So, do you guys remember how to change degrees into radians? Oh, oh no, I just hit my caps lock. Okay. So, here we go. I did purple, red, I got green. Okay. So I have 30 degrees. How do I change that into radians? Remember? 30 degrees times change degrees into radians. I'm going to just go down a little bit. Change degrees into radians is times pi over 180 degrees. That's how you convert it. Remember that? We did that before the break. Degrees cancel out. You can cancel out the zeros. 3 pi over 18. Both divisible by 3. Here, let me try to get rid of my the glare. Sorry, I see my glare in the way. Okay, divide by 3, and I get pi over 6. So what's that saying? 30 degrees is equal to pi over 6 radians. And you can do that with all of them. What's 45 degrees? 45 degrees times pi over 180 is equal to, think, 45 pi over 180. You guys see that? They're both divisible by 45 is equal to pi. 45 to 45 is pi, 1 pi, over 4. So 45 degrees is equal to pi over 4. "60 degrees is equal to pi over 3. Did someone say something? Someone say something? Thought I heard something. I don't know if it's coming from my house or not. So 60 degrees calculated out is pi over 3. 90 degrees is pi over 2. 120 degrees is 2 pi over 3. 3 pi over 4. And then 5 pi over 6 is 150 degrees. 180 degrees is equal to pi. I'm going too fast. 210 degrees is 7 pi over 6. 225 is 5 pi over 4. 240 is 4 pi over 3. 270 is 3 pi over 2. You can calculate these out if you don't believe me. 300 degrees is 5 pi over 3. 315 is 7 pi over 4. And 330 is 11 pi over 6. And 360 is 2 pi. I think there's a rapper named after him, like 2 pi. Thug Life. Is that what his name was? Was it 2 pi? I don't remember. And then 0. Oh, can you guys see that? That's the whole unit circle. So now we got to graph sine and cosine using the unit circle. You guys see the whole thing? Oh! I'm going a lot faster than my other class. Hopefully I'm not going too fast. But we're not done yet, so I'm going to get rid of this in 10 seconds. 5, 4, 3, 2, 1. Okay, now remember, we were talking about here, this point here, this is my x, this is my y. When we calculated, we said, hey, this is equal to the cosine, and the y is equal to the sine. So the only thing after all that, if you're wait, I don't remember that, Sensei. The only thing I need you to remember is this. Write this down on your unit circle. Sine equals x. Nope. Oh, sorry. Cosine equals x. Cosine equals x. And sine equals y. The way I remember it, alphabetical order, C comes before S, just like X comes before Y, right? The first ones go with the cosine. X is first, cosine is first, X is fourth, X alphabetically, sine is first, Y is first alphabetically. But whatever, cosine is X, sine is Y. Cosine is equal to X, sine is equal to Y. Okay, let's graph sine and cosine. Here we go.
What? Sis, can you wow, somewhere else? Can you go somewhere else?
Can you stop screaming, nigga? Jesus.
I am
Don't know, your mic's muted.
look at my Nintendo. Okay?
Hey, Donnell. It's okay. I know it happens. Okay, so let's graph sine and cosine. There we go. And so we're going to do coordinate plane. Hey. Coordinate plane. Tech Deck's not really the best for making lines. Okay. So this is my y coordinate, this is my x coordinate. Okay. Now here's what we're going to do. I like to skip one, and we'll do this one. We'll call this point pi over 2. Where did I get that from? Pi over 2. Let me rewind. We're going to use these numbers, x coordinate, y coordinate, x coordinate, y coordinate, x coordinate, y coordinate, x coordinate, y coordinate. Now these, negative root 3 over 2 and 1/2, negative root 2 over 2, root 2 over 2, these are going to be really hard to graph. You know what makes it easy to graph? The zeros and ones, like the matrix. Zeros, so we're going to graph the zeros and ones. Zeros and ones. Pi over 2, pi, zeros and ones, 3 pi over 2, and our famous wrapper, 2 pi. Okay? So we get pi over 2. The next one we're going to do pi. So, where's my... Oh, there it is. Okay, pi over 2. Next one, skip 1, pi. Skip 1. Next one, 0 and 1, is 3 pi over 2. And then finally, 2 pi. But now let's go backwards. Okay? Backwards will be negative pi over 2. And then negative pi. And then negative 3 pi over 2. And then negative, famous wrapper, 2 pi. There's our coordinate plane. And let's only go up 1 unit. I skip 1 to make it a half, make each one worth a half. Oh no. This will be negative 1. Okay. Graph the zeros and ones. What is the matrix? All right, here we go. What should we graph? Sine or cosine? Kayla, what do you want to graph? Sine or cosine?
Sine.
All right, Kayla says graph sine. So we'll say y equals sine of x. We're going to graph y equals sine of x using the unit circle. Kayla, do you remember what sine equals?
Sine equals 1.
Sine equals y. So remember, all my y coordinates are going to be my sine. Y, sine, 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 right? All the y's. But we're only going to graph the zeros and ones. Okay. So here we go. Here's the $1 million question. You ready? What is sine of 0? Sine of 0. Jose, what is sine of 0? Looking at your coordinate, looking at your unit circle, what is sine of 0? Jose?
0.
0. My y is 0. Sine of 0 is 0. So we go here. 0 is 0. What is my sine pi over 2? So let's look at pi over 2. What's my sine? Let's go with Joshua. What is sine pi over 2?
1.
1. Got it there. 1. So we go up at pi over 2. We go up to the 1. Okay. Sine of pi. Let's go with Jasmine. What's sine of pi? Sine of pi. Here's my pi. What's my sine? Jasmine! Jasmine, don't make me get off my presentation. Where are you? Where is she? You don't know where Jasmine is? Did she leave? Jasmine? Jasmine!
Sorry, I went to the bathroom.
All right. Stay with us.
Okay, I'm sorry.
I'm going to ask you a question in a second. Jacob, where are we at? Jacob, what is sine of pi?
Would it be 0?
0. Why? Sine is y. That's 0. So look, we go pi. We go back down here to 0.
You're not presenting anymore.
Okay, stop.
Jacob, you saw that without me presenting. Very good. I'm very proud of you. Okay. Sine of pi. We have pi here is 0, which is here. So then we go pi. We go back down to 0. Okay, 3 pi over 2. What is sine of 3 pi over 2? 3 pi over 2 is right here. Let's go with Jaylene. What is it? 3 pi over 2 right here. What's my sine? Oh, come on. We're not going to get through this class. People and answer it. Jaylene.
Sorry, I didn't unmute. I didn't unmute. Is it negative 1?
Yes, very good. Negative 1. Thank you. Sorry about that. Just trying to get it done. Okay. Jasmine, you're up. What is sine of 2 pi, our favorite rapper? Jasmine.
0.
Very good. 0. We got 0 here. So now look. Sorry, right here. Watch what happens. Connect the dots. Ooh, look how cool that is. And it keeps going. You keep going. Now, negative pi over 2 would be going in this direction now. Negative pi over 2 would be negative 90 degrees in this direction. Sine would be negative 1. So then I go here, negative 1. And then negative pi would be negative pi in this. This is the negative direction. Would be right here. My sine would be 0. So we go back up at 0. And then negative 3. You can start seeing the pattern. I go down, up. I got to go back up to 1 here. And then negative 2 pi, I go back to 0. And then that is my sine graph. The thing is, these need to be curves. Don't make them pointed. I'll mark you wrong with that. They need to be curvy. Curvy. And that's y equals sine of x. That's how you graph sine of x. Because sine equals y. Are there any questions? No? Almost done. We're going to graph cosine. X, Y. Okay, I'm just doing the coordinate plane. Same thing as before. Pi over 2. Pi. 3 pi over 2. 2 pi. Negative pi over 2. Negative pi. Negative 3 pi over 2. And then negative 2 pi. And we go, let's go up 1. Negative 1. X, Y. Okay, here we go. I'll let you catch up if you haven't caught up. Okay, here's my $1 million question. What is cosine equal to? Let's see. Oh, Gracie, what is cosine equal to?
X.
Cosine is equal to x. So we just look at our unit circle, just find all the x's and graph the x's, right? Cosine of 0. What is cosine of 0? Eric Jones, what's cosine of 0?
Cosine of 0?
Yeah.
Which one is that?
You look what I'm pointing at? Is this helping or not, Eric Jones?
Yeah, it equals x. But...
Okay, great. What's cosine of 0?
1?
There you go. Cosine of 0 is 1, so you got to get it here at 1. Eric, does this make sense or no?
Yeah, I understood the sine, but I just got caught off with the cosine.
Yeah, it's x, though. Sine is the y, just cosine's the x.
Yeah.
Well, we'll get to the next one. Just listen up. Okay. Brandon, cosine of pi over 2. Look at your unit circle and tell me what it is. What is cosine pi over 2?
0.
There you go. Anyone need me to show that? Can we move on? While you're waiting. Annika, what is cosine of pi?
-1.
-1. Boom. Nice. Okay, let's go with Isaac. Cosine of 3 pi over 2.
0.
There you go. It sounds like you guys are getting it, so we can move on. Let's see. Jaylene. Cosine of 2 pi. Your favorite rapper. Is he a rapper? Jaylene.
Wait, which one?
2 pi.
Is it? No, I don't know this one.
Ah! Jaylene, what have we been doing this whole time? Where are you? Jaylene.
No, I was with you in the beginning, but right now I lost you.
When? When did you lose me?
When
I need
you
to look at
started
you. Are you in bed or what are you doing? Are you sleeping or something? Where are you, Jaylene?
I just answered a question when you asked me right now. Like I knew the first part, but right now I lost you.
Jaylene. Jaylene.
Yes.
What'd you have for lunch?
I haven't ate.
Oh, you're probably hungry. Are you hungry?
Kinda.
Okay, Jaylene, are you looking at my screen?
Yeah.
Okay, Jaylene, what is cosine equal to?
X.
Cosine's equal to x. Look at your unit circle. Are you looking at it?
Yeah.
Okay, what's 2 pi? What's cosine of 2 pi? Jaylene.
I don't know. I don't know.
Jaylene. Jaylene, you
Yeah.
with me?
Yeah.
See where my 2 pi is?
So is it 1?
1. Very good. That's what I'm talking about. So we have here, we go up to 1. We just go like this. It's just the x, Jaylene. Yes, no?
Yes.
Okay, good. All right, let's do the negative pi over 2. We go in this direction. Negative pi over 2. Jaylene, what's my cosine for that? We're going this direction. What's my cosine? Do you remember what cosine is equal to again?
It's equal to x.
Yes, very good. Do you see an x and a y here?
0.
Yes, very good. Okay, cool. Let's go here. Let's go with, let's see, negative pi. Let's see if someone can get this without me showing it to you. Negative pi. Can you tell me what cosine of negative pi is? Jose, can you tell me what cosine of negative pi is?
-1.
100% correct. Very good. We're going the other direction. So we go here. Negative pi is -1. Okay, negative 3 pi over 2. Remember, going backwards on the unit circle. Hopefully that makes sense. The backwards is a little bit more challenging. Let's say, John, what is cosine of negative 3 pi over 2?
Did you say my name?
I did.
Oh.
Say my name, say my name.
Is it... Wait, what was the question again?
What's cosine of negative 3 pi over 2?
1/2. Or -1/2.
Where'd you get that from? Tell me your train of thought, John.
I just went for it.
What, you just went for it?
Yeah, from the unit circle thing.
Just went for it? John, negative 3 pi over, remember, John, do you know what cosine's equal to? Yes, very good. Negative 3 pi over 2 would be this direction. Can you see my finger or my pen? Negative 3 pi over 2. There's negative pi over 2. Negative pi. You following me, John? Negative 3 pi over 2 would be right here. Because 3 pi over 2 is this way, but in the negative direction, it'd be right here. 0. Thank you so much. That's all it is. Go back up to 0 right there. You guys, and can you see the pattern? Okay, the last one is negative 2 pi. Let's see. Let's go with Jacob. Negative 2 pi. Come on, Jacob. You can do it. Come on, Jacob.
It would be
yes.
1.
Amazing. The negatives are hard. And so that is my y equals cosine of x graph right there. And that's all you got to do. So there's your sine of x and your cosine of x. Tomorrow's going to get a lot more challenging with these graphing because we're going to put parameters. You guys remember h and k? Well, guess what? And a, they go in this. Are there any questions? For your homework, everything that we just did, just take a picture of it and send it to me. That's all you have to do for the homework today. Okay, but make sure you know how to graph sine and cosine. It's important that you do. Okay, if you don't have any questions, you may go. I'll see you tomorrow. Bye, Taylor. Bye, Jacob. Bye, Jasmine. Bye, Natalia. Bye, Brandon. Bye, Kayla. Bye, Marilla. Bye, Roberto. Bye, John. Bye, Giovanna. Bye, Ethan. Bye, Eric. Bye, Jay. Bye, Matthew.
I have a question.
Yes, what's up, Ariana?
So do we turn in the circle when we turn in 8.4 since you put it together to turn it in?
That was 8.3.
Yeah, but
8.4 is
to turn in the circle, you put it under one whole thing of turn in and uploading it circle. And
oh, yeah. Just like, at the end of the week. It's due at the end of the week.
Okay.
Like normal. I try to keep it the same.
All right.
Okay.
I forgot to stay yesterday for the abstinent thing. That you told
man,
me.
I think. Oh, I fixed it.
Oh, okay. Well, thank you.
I remembered. I remembered that you were there. So, all right. All right, Jose.
I came in late today.
Okay.
Yeah, the same thing.
Ishi. Oh, there you guys are. What time did you guys come in? How many minutes late were you? Isaac, how many minutes late were you?
Like 2 minutes, maybe. 1.
No way. I took roll after 2 minutes. How about you, Ishi?
I was like 30 minutes late. I was at a doctor's appointment.
Okay. All right. Do you guys have any questions? I marked you here.
Are you going to post this recording today?
Yes, I will.
Okay. That's all.
Okay. In fact, when we hang up, I'll do it right now.
Okay. Thanks. Bye.
Okay. See you guys. Bye, Isaac. Hello? Natalia.
Which section do we turn in the unit circle in?
You do it on Friday. It's the I think I said is 8.3 and 8.4 in the. It should say to let me check my Canvas. Yeah, it says unit circle and 8.4.
Do we turn it in today or until Friday?
Friday.
So we don't have any homework for today?
No, it's just like no, as long as you copied everything I did, you're good.
All right. So as long as we understand it?
Yeah, for sure.
Okay. Thank you.
All right. Okay, I'll see you, Natalia.